Get ready, strap yourself in. We are getting ready to do Venn diagrams with 3 sets or 3 circles. But that's as adventurous as it's going to get. You can do Venn diagrams with more, but as you start increasing the number of subsets to put on there, you can't use circles anymore. You start using some crazy shapes. But anyways, we're not going to go that far. We're just going to do up to 3 sets. So let's see what we got next. When we go to fill out a Venn diagram with 3 sets, we're going to have 3 overlapping circles. And your aim is to try to start in the middle and kind of flower your way out. You're going to fill in elements that are common to all 3 sets, which will go right exact smack dab in the center where all 3 circles overlap. Then you work your way out and look at what elements only appear in 2 sets at a time and not that 3rd set, and put those in the rest of the overlapping regions, just not in that exact center. And then finally, for the circles, fill in the elements that are only found in 1 set, and those go still in the circles but not in any of the overlaps. And then when you're done, go back to the universal set, see if there's anything that was left out, and those go still in the rectangle but outside the circles. So it's very similar to the 2-circle one, except you've got more regions to do. So instead of having 4 regions to worry about, you have 1, 2, 3, 4, 5, 6, 7, 8 regions to worry about. Alright, so let's look at an example of how to fill one out. That's the best way to explain it, is just to do it and show you how it works. Okay, so let's say that we have, I keep switching that to red and I want to write in black, so let me switch the color. Sorry about that. Okay, so let's say we have a universal set that contains A, B, C, D, E, F, G, H, I, J. Okay, and then out of that universal set, we're going to make a set A that contains C, D, E, G, H, I. In case you're wondering, I am pulling this out of my current textbook. It's on page 70 and it's question number 8. I like letting other people come up with problems and then just using those. Much easier. Okay, so C, D, E, G, H, I. And then set B contains A, C, D, G. And then set C. So now we got 3 subsets, so we got to have 3 circles. C, F, I, J. And our job is to make a Venn diagram representing all of these sets. Okay, so it doesn't hurt to make it kind of big, just to make sure I've got plenty of room to do my drawing. I hate trying to squeeze things in. When we go to draw our circles, we're going to draw 3 overlapping circles. So the first 2 look like that MasterCard symbol, and then the 3rd one joins it down here. It's kind of like the Olympic rings with only 3 rings. Okay, so we go A, B, C. Like that. Okay, first things first, this middle region here, this region here is going to be where we put the elements that are common to all 3 sets. So right in there. So all 3 sets, let's see here, all 3 sets have a C. So we're going to put a C in here. Why is it doing that? I didn't click anything. And what else? Do all 3 sets have anything else? No, that's it. All 3 sets just have a C in common. Okay, next we're going to look at the rest of the overlap parts. This little overlap right here, we're going to look at what's just in A and B, but not also in C. So in A and B, we have a G and a D, and that's it. This little overlap, we're going to look at what's in A and C, but not B. So in A and C, we have an I, and that's it. And then for this little overlap, we're going to look at what's in B and C and not A. And it looks like nothing. Sometimes you're going to have regions that are left blank. So the intersection of B and C is the empty set. So you'll notice there, it's the empty set or the null set. You could also write it like this. B and C and not A. Why do you keep doing that? So just B and C and not A. So that part there. Alright, then working our way further out, set A, what are we missing still? We already have C, D, we need E, G we have already, H, and then I we have already. In set B we need an A, we already have C, D, G. Set C, we already have C, we need an F, we have an I, we need a J. Then universal set, let's see, we got A, we don't have B, C, D, E, F, G, H, I, J. And that's it. So there you go. So there's how you fill out the Venn diagram with 3 sets. Now if you're working with 3 sets and they're asking you to analyze a Venn diagram, again, use the set order of operations that we reviewed in the last lesson. Let's see. Let's say you have this Venn diagram. I'm pulling this out of page 72 in the current textbook, exercises 39 through 50. I swear it's so hard to draw straight on this tablet thing. I don't have like an iPad or tablet PC or anything like that because I don't have the money for that. I have a little bamboo tablet and it's getting rather old. And it's getting harder and harder to use it. But anyways, do what you can. So, my videos will never be Hollywood quality. They always have a certain charm, right? At least that's what I tell myself. Alright. Just fill in this Venn diagram. I've got this Venn diagram again off page 72 in the current textbook. But anyhow, if we're not in the same current textbook, if we're not in this book-to-book anymore, then don't worry about it. Just, at least you know what the Venn diagram is because I wrote it there. Okay. So here's the Venn diagram. Oh, and the subsets are A, B, and C. Now, one of the questions they ask is for us to figure out B intersects C complement using this Venn diagram. Well, again, use your order of operations for sets and tackle what's in the parentheses first. Figure out what's in B intersects C. Now, when it says B intersects C and it doesn't say anything like not A, then you need to include the entire intersection. So in this case, you need to include 4, 5, 6, and 8. Because you're looking at the entire overlap of B and C. Now if they had said like B intersects C and not A, then that would be different. That would be just the 6 and 8. But they didn't say that. So. Then once you've tackled what's in the parentheses, you can work your way out. And outside the parentheses, we have a complement. So that complement means every other element that's in this Venn diagram except 4, 5, 6, and 8. So we're looking at 1, 2, 3, not 4 and 5, 6, but then 7, not 8, 9, 10, 11, 12, 13, 14. I think that's everything. So all the other elements in that complement can be found in any of the circles or out here in the rectangle space outside the circles, just not 4, 5, 6, and 8. So that's what's happening there. Okay, so just make sure you follow whatever that order is still, even though there's might be 3 sets involved in a bigger Venn diagram. Let's see here. Let's say we have same Venn diagram, and we want to do something a little more complicated. All right, let me just re-sketch it real quickly here so that you have it to look at. Okay, so let's say they do ask you to do something with like 3 sets. So let's say they say A intersect parentheses B union C. So the parentheses B union C tells you to start there. It's like book. Alright, B union C, you're taking everything from B, everything from C, and putting it together in one set. So we need a 3, a 4, a 5, a 6, a 7, an 8, a 9, let's see, an 11, a 12, and a 14. And then when we go to do the intersection, we need to make sure we know what's in A. A contains a 1, a 3, a 4, a 5, a 9, a 10. As long as it's within the confines of that A circle, it's fair game for set A. 1, 3, 4, 5, 9, 10. All right, then finally, to do the intersection, look at what's in common. What do A and then B union C have the same? They both have a 3, they both have a 4, they both have a 5, they both have a 9. They do not both have this 1 or this 10. They also do not both have 6, 7, 8, 11, 12, or 14. There you go. Plenty of those to practice. Now sometimes you're going to be given 2 statements, much like the ones we were just working with, and you're going to be asked to decide whether the statements are equal. But they might not give you elements to go in the circles. They might just say, assuming generic sets, like we don't know what the elements are, let's figure out, are these 2 statements equal? In other words, would these 2 statements have exactly the same elements, no matter what elements we use to make up the set? So you're basically going to be doing a proof. You're going to show whether or not 2 statements are equal, no matter what the scenario, no matter what the situation. And then to do this, since you're not given elements, what you can do is take a blank Venn diagram and then label the different regions with numbers. And then basically use those numbers as like elements. You're only going to put 1 number in each region. So like if you have 2 circles, the region with just A is number 1. The region where they overlap is number 2. The region with just B is number 3. And then all that space outside of AB is region 4. If you've got 3 circles, just A is 1. A intersect B but not C is 2. Just B is 3. A intersects C but not B is 4. A and B and C all intersect at 5. B intersects C but not A is 6. Just C is 7. And then outside of those circles, that part is 8. So use those region numbers, and then you go through each statement and see, well, what would be the set? Just like we were just doing with figuring out the sets with like A intersect B union C kind of questions. You're going to take whatever statements they give you, and you're going to figure out, what would the final set have in it, just using these region numbers. And if the two statements end up with the same exact sets, then you know the two statements are equal. Because whatever the elements are, they're going to both have the same elements. If the two statements end up using different regions in any way, then they're not equal. Because they'll have one of them will have something different from the other. Alright, let's look at an example. Let's just start with two circles first and do an example. Let's say you have the statement A complement intersect B complement. And you want to figure out whether that's equal to the statement parentheses A union B close parentheses complement. Now since there are two regions, A, B, we're going to use the Venn diagram with two circles and four parts. There's two subsets, A, B. I said regions, sorry. Two subsets, A, B. We're going to use a diagram with two circles with four regions. I'm using Roman numerals to number it, but if you aren't comfortable with that, you can just use regular, you can do Arabic numerals. The numerals you're used to, the 1, 2, 3, 4. Alright, so starting with A complement intersect B complement. There's no parentheses, but complements come before intersection. So first looking at A complement. Well, the A circle has regions 1 and 2, so A complement is everything else. So that in this case regions 3 and 4. Then for B complement, B has 2 and 3, so B complements everything else, which would be 1 and 4. Then to do the intersection, you're looking at the two results we just got, and you're seeing what do they have that's the same. Well, 3 is not in both, 1 is not in both, but 4 is. So they both have region 4. So they both have any elements that are found in that region. Alright, moving over here, let's do this one. This one does have parentheses. Let's tackle those first. A union B inside the parentheses. Remember, A union brings it together. So we're taking the 1 and 2 from A, the 2 and 3 from B, bringing them together into the same apartment. 2 is a duplicate, so we'll throw one out and keep one. We don't need that many spoons or measuring cups or whatever. Okay, so it's going to have regions 1, 2, 3. And then working your way outside the parentheses, the complement's outside. So it's saying take whatever result you just got and include everything else except that, which would just be region 4. And notice that both have the same region. So whatever elements we're dealing with, both sets will have the same elements. And if they have exactly the same elements, then that tells us the two sets are equal to each other. They're also equivalent because they'll have the same number of elements. But since they have exactly the same elements, we can say they are equal. Yay! Now I cheated a little, and the example we just did is actually an example that's so very widely used and very widely known as part of something called De Morgan's laws. You're going to have more problems other than these, but I just kind of cheated and used one of De Morgan's laws to demonstrate how to handle these problems. De Morgan's laws, these have already been proven, but you can go ahead and prove them both yourself. We just proved one of them. You can prove the other the same way we just did, using Venn diagrams and regions. But anytime you have a union in parentheses and a complement outside, that's the same thing as taking the opposite or the complement of whatever the first one is, flipping the sign in the middle, and then taking the complement of whatever the second one is. And that comes out the same. So if you have a union, it's equivalent to an intersection. If you have an intersection, it's equivalent to a union. But you must take whatever the first part is and do the complement of that. Take the second part and do the complement of that. Or vice versa. If you don't have the parentheses, it's kind of like factoring out a negative. You can put parentheses, do the complement of the first, complement of the second, change the sign in the middle. Just make sure you put the little complement outside. Alright, let's do an example with 3. So I just did an example 2. So let's do an example with 3 so that you can see how that works. Let's say you have something like... Oh wow, that one looks pretty good. You probably dread hearing me say that, because usually when I find fun or looks pretty good, you guys go, oh man, what is she doing this to us for? Alright, we got parentheses, A union B complement, intersects C. That's the first statement. And the second statement we have parentheses, A complement, union C complement, close parentheses, intersection, parentheses, B complement, union C, close parentheses. Since we're dealing with A, B, and C, let's go ahead and draw the 3 circles and label out our regions so that we can have this little reference to help us. Okay, just starting up here, just working our way across. We got 1, 2. Make sure when you do these problems, you label your regions the same way. It'll make you consistent and cut down on mistakes. 4, 5, 6. Like, don't jump all over the page doing your numbering. Just across, 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 like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so first statement. Got a lot going on here. Let's take it piece by piece. First piece we have to tackle is the parentheses, A union B. So take everything in A circle, everything in B circle, and put it together. So we got 1, 2, 3, 4, 5, and 6. Then A union B complement is everything else in that rectangle except 1, 2, 3, 4, 5, 6. So it's not much actually, it's just 7 and 8. Okay, then we have to do intersection C. So let's go ahead and list what's in C. So if it just says C, make sure you list everything in C. People will often forget something that's in one of the overlaps. But look at the entire C circle, and you have a 4, 5, 6, and a 7. Then you go to do the intersection of A union B complement with C. Well, A union B complement had 7 and 8. C had 4, 5, 6, 7. So for the intersection, they both have 7. And that takes care of that. Now let's see what's going on with this other statement. Two sets of parentheses. Doesn't really matter which one you tackle first, but I prefer to go left to right, so I'm going to tackle the A complement union C complement first. So in the parentheses we have this complement. I don't really need that parentheses because right now I'm just going to write down what A complement has. Everything outside of the A circle. The A circle has 1, 2, 4, 5. So outside of that is 3, 6, 7, and 8. Okay, then we need C complement. C has 4, 5, 6, 7. So we need everything else. 1, 2, 3, and 8. And we're doing the union of those two. So we got 1, 2, 3. 3 appears in both, but we just write it down once. There's no 4 or 5, but there is a 6, a 7, and an 8. See if I can just squeeze that in right there. Now I don't want to do that intersection in the middle yet because I got to do this other set of parentheses here. So I need to write down what B complement is. See, B has 2, 3, 5, and 6, so we need everything else outside of that. 1, 4, 7, and 8. We got C. C has, it's not C complement, it's just C, so we need to write down what's in C's circle. 4, 5, 6, and 7. And then to do B complement union C, I'm taking everything from B complement, everything from C, putting it together. 1, 4, 5, 6, 7, and 8. And then we gotta take this A complement union C complement and this B complement union C and do the intersection of those two. Alright, so intersection. We both have a 1. 2 and 3 are out. 4 is not common. 5 is not common. 6. They both have a 6. They both have a 7. And they both have an 8. Alright, that takes care of that statement. And the two different statements here are very different in their results. They both have a 7. The statement on the right here also has a 1, a 6, and an 8. So these two statements are not equal to each other. To be equal, they have to have exactly the same regions. And you can't leave any out. So there we go. Those two statements are not equal. And that happens sometimes. Sometimes they're equal, sometimes they're not. Alrighty. Well, that takes you through the 3-circle Venn diagram. This is leading up to our big conclusion with applications. Applications, you're going to have to be able to use 2 circles and 3 circles to do these different problems. You're going to be taking scenarios and drawing Venn diagrams, and then using those Venn diagrams to help you answer some questions. So it's, yes, it's word problems, but not quite the same as what you're used to in like algebra class or something. So that's where we're heading. So practice these 2 and 3 circle Venn diagrams, and when you're ready, tune in and we will talk about the applications. Thank you for joining me.